Anyone here from Los Angeles? Any Los Angelinos here? That's a trick question because I know there's like a lot of you, but thanks for acting like you're enthused. Anyway, so my talk is called Handling Null. My name is Evelyn Masso, at Out of Ambit on many social media, including Twitter, Instagram, not Snapchat. I'm too old for that, I'm sorry, and other things. So feel free to @ me somewhere or talk to me afterwards or during. So a little bit about me. Again, my name is Evelyn. You'll see that I identify a lot more with my dating profile than with my LinkedIn profile. But if you're curious about what I work on, most of my time is spent working on GitHub Desktop and processing P5.js. So I spend a lot of my time in the open source world, a lot of my time writing JavaScript actually these days, and TypeScript. So a lot of this talk will be drawing from some of these other languages that are also functional and typed and interesting and can like learn things from Elixir patterns and vice versa. So to get the ball really rolling, what is null anyways, right? Like this is a word, who here has used null before? Like I think most languages pretty much, I mean not all, but like many languages and frameworks support null, right? Whether it's Elixir or TypeScript or C++ or like whatever, like there's some null, it might be called something else. Well, first of all, like in Latin, null translates into not any. So it's kind of this idea of an empty state where there's like, there could be something here, but there isn't right now. There might be later though. So some other names for null. Null also goes by nil, nothing, none, depending on the language you're in. I think Elixir uses nil. I believe Python uses none. Nothing is somewhere else that I don't remember. But these are all kind of the same concept, right? It's like some kind of like primitive type that is specifically like intended or used rather for there to signify like a lack of something that could be there otherwise. Now this is like really interesting because like how do we use something like this, right? Like in most type languages, you want to, if you have the possibility of something being there, it probably makes sense to define what that possibility is, right? So like this is an option type. We have a type we're going to call it nullable, and it's templated on T, where it's a union of either null or whatever the T type is. So for example, so for this example, right, this is just saying that like whatever the type is, it can be that type or it can be null. So it's either T or it's nothing. For example, it could be a number, so null or a number. This is TypeScript syntax, but the basic idea is that like nullable templated on number gives you a type that is a union of null and the number type, right? So numbers can be integers, floats, et cetera, et cetera. Cool. Does that seem reasonable so far, right? We're sort of like tying this in really definitively with like something being there, a particular kind of something, a type of something, and nothing. So the funny thing is when you go to use this can be really useful. I mean, this can be really useful, right? So like in our function here, we have an argument called amount, and there's this argument called nullable, or amount, sorry, which is a nullable number. Now, before we can use this number to do anything, we have to check and make sure that it's not null, right? So like if amount is not equal to null, then do something. Otherwise, we have to do something else. Now, this is awesome, like because we're representing our state here in that it can be nothing or a number. But it's kind of annoying that we have to do this type check right here. We're like, oh, like this could be a number of things. There's one case in particular I have to check for, and assuming that's not true, then I can do some things. Otherwise, I have to like have a special case that's particularly centered around the case where it's null. In TypeScript, this is called type narrowing, but that works the same way, of course, in like Elixir and other languages that have static type checking. So as an example, to make this a little bit more concrete, outside of like the lofty realm of types and unions, let's look at a drop-down menu state. So has anyone here seen The Hunger Games? Anybody? Or read The Hunger Games? OK, cool. The rest of you, I'll catch you up in a second. So in The Hunger Games, there's a protagonist. Her name's Katniss. And while the novel has very little to do with this, it's actually largely focused on the overthrowing of an authoritarian regime. There's a subplot where Katniss has like a choice. It's kind of like a who is she going to date sort of situation. Like, is she going to date Peeta or Gale? Some of you may remember this theme from shows and movies like Twilight or every romantic comedy ever made. So to catch you up a little bit more, like this is Peeta on the left, Gale on the right. You can see it's kind of like a tall, dark, and handsome versus like a good kid sort of vibe. Very stylized in this particular example. But a decent amount of this centers around like who is she going to date in the movies. So we have a drop down here that says whomst should Katniss date. Peter or Gail, right? So we have like 3 states here. This can be either whomst, which may in your initial implementation be used as null, right? Or some sort of like empty value. Like this could be Peter or Gail, or it could be null, which works great like in terms of like a first implementation, right? Like we capture all the states we care about in this UI. Now let's say like as we go through, we have our like, we can say this is like a survey sort of application, right? We're sending out these surveys, and we're collecting information, we're storing it in a database or something along those lines, some persistent data store. Let's say we are moving along, we have some like new constraints or some new things we want to add to our form. Like let's say there's a new challenger approaching, right? Like there's someone else we want to add to this form. Let's say like Katniss could date Peeta, Gail, or Hermione. Okay, so that scales pretty well. We can add a 3rd person here, and like that's totally fine. Like our data model is set up for that. But if we start to question some of our assumptions about this whole like model, the way we built this form, like let's say we want to say like, oh, we want to explicitly say Katniss should date nobody. Then what do we do, right? In this case, no one might be something you would use null to represent. But null is what we were using for no response as well in the past. So like, what do we do? Like we now have, if we refactor our form to use null to represent this new value, we're sort of taking all the data that we threw away before and assuming that those people were saying no, and where they may be saying I don't know, I don't care, other things like that, right? So we've sort of like introduced some like interesting tension to like how we represent our data. So you might want to do something like this, right? We have no one be a specific type or a specific option in the form, and we still have a null state, which is whomst, where there's no answer. Now we're still throwing away some data here, right? We still don't know if people think, we still don't know if someone doesn't care, or if they don't know, or if they like have questions, or if they have like another person they would rather have on this list. So it's a little bit like, we're getting closer to like a data model that really, captures like a lot of the different options that exist. But like we've definitely sort of like grown as developers and as surveyors, in that we're collecting more information and representing it properly in our data model than we were before. So this kind of gets to the trade-off. The trade-off of using null is that it's convenient, it's already built into your language, but we might have to refactor things later. We might have to take null and kind of tease it apart into a number of different states that we are all lumping in together as one particular type. And not only that, null can sometimes leave us in a state where we're not sure what it represents, right? It's just like the not anything else sort of category, which again, it turns into that kitchen sink of like everything that's not in this form. That's fine if we're trying to move fast and we just want to like get this form out the door and like have a data model that sort of like is good enough for our current purposes. But once we sort of like once we start to question our assumptions or have to rework some of our data model, we have some issues here in terms of like how we're going to really refactor this and like tease apart the particulars of what Null's been concealing from us along the way. So when to use null? Like let's talk a little bit about like when it's a really good idea. Like you definitely want to do this. So obviously, as we already talked about, like when something can optionally exist, right? Like it's null or something else. We also want to make sure we're using it when instead, like if we find ourselves doing a data model and we start special casing things around like particular values like -1 or 0, false, like in certain, like you might like make a type that's like a union of false and then like a number, which in that case false is just a stand-in for null, but is like even more removed from like what the actual meaning of that type is, right? So that's another time we might want to say like, okay, like if we find ourselves sort of using that special case pattern that's centered around particular numbers, like null might be a more communicative way to represent that data. And then finally, it makes, in my opinion at least, in my humble opinion, it makes more sense for data structures than it does for like arguments or like constructs that you're passing around through functions. Because like if you use it for like a data structure, whether it's a model in a database or something else, you can check for null like early on in your like list of callers, and then like after you check for null once, you can type it such that the null is no longer possible. And so you can sort of remove null early on in the stream of functions, as long as you start from like the beginning, like the source of the data. And of course, like we're assuming we're type safe here. If you aren't type safe, then null is a much larger problem because it exists and you don't really know. Well, you don't know for sure whether it's a possibility or not in many places. Okay, so those are some good times to use null. But when are some good times to specifically avoid using null? We talked about a couple sort of like catch-22s about it. So so some ways you might want to do it is, or some places you might want to avoid null are when there are multiple ways something cannot exist. And you care about those different ways. If you don't care at all about those different ways, then null might be totally fine for your use case. But if there's multiple ways something cannot be a number or not be some range of values, if there's some other like range of things that it could be, then that might make more sense to use to avoid using null. And so this kind of ties into the idea of future-proofing your data model. Like, how do we make sure that we don't have to refactor our data model later, assuming that it's worth the time and effort it takes to do that design and implementation up front? So what I'm saying is, what are alternatives to null? Like, what can we do in those cases where we would want to use null, but maybe there's a better way? Maybe there's some other options we should consider. So one way we can do is we can use explicit cases here. So going back to the example of having a survey form where we collect people's opinions on who Katniss should date, we have a number of people. Like we have, in this case, I'm using TypeScript enums. So people, Peeta, Gale, Hermione, are like the choices we saw before, the earlier versions of the form. But then there's also an enum of options where it's like, oh, no one, someone else, unknown, and you can enumerate other sort of like exceptions or like non-person entities or choices in this enum. So now we have like a sort of like more complete picture of like what the different ways something can exist and not exist are. And so basically the type for this like dating options survey would just be like people or the options from before. It's a union of those two particular enums. So that sort of like solves the problem of throwing away data, right? We have all the options, and then we take the ones we care about. Like even if we accept this data and represent it in the form, we don't even have to necessarily store it in the database like that, right? Like in our persistent data store, we can throw away this information if it's something we truly don't care about, at least at the time. Again, like if you come to that situation later, like that's something to address. But it's at least the front end or like the interface and the sort of like the upper layers of this application support like this fidelity of understanding. And so again, this like really applies to like incoming data, right? This is about like representing the choices as the person enters them. The other way we can do this is having something like a default value, or this can be accomplished with like factories or default values in functions. There's lots of ways to have this, but basically to say like, assuming this value is not passed or not provided, here's the default. So in this case, we say like, here's some like different dates or none, and if you just don't pass any of them into this function, then the default is .none. So it's an option, and if it's not stored, then the way that we can be represented outgoing is to say like, okay, we'll just assume it's none if the value is not there. So again, this is more like on the other side of the data flow, like where data is coming out of the models and going up into the presentation layer. We can say like, okay, like even if it's not in the model, we can guess or have at least like a sensible default that's represented very explicitly at the presentation level. So again, this comes back to the trade-off. Again, it's like, do you want to spend time up front doing this extra work of like defining your different like exception cases? In some cases, you know it's going to be something you have to do eventually, and so it might be worth doing the first pass. Of course, that goes a little bit slower, so the alternative is to skip that and say like, okay, this is null is good enough, or some sort of like, yeah, some sort of null construct is good enough. And we can, if this becomes an issue later, we can come back and sort of like revise and iterate on the initial data model that we used. So in that particular case, I would say the choice is really up to you, like what you want to do exactly. It just requires a few seconds at least of forethought about like explicitly making that choice of like whether we want to invest in the data model or iterate on it later, assuming that even happens. So much like Peter Parker and Miles Morales, you can sort of like ponder this together. I identify a lot with the person in the costume. And that's the talk. Thank you.